Bismillahirrahmanirrahim. Assalamu alaikum and welcome to my channel Mathstatic. Uh, Before going into the lecture today, I'll ask you to please subscribe me, like me, and share with your students and colleagues. Today, inshallah, we'll be studying subtracting and addition of the algebraic terms or algebraic expressions. I think we'll be doing the preamble of exercise number 2.3. It is very easy and it's just like uh, the simple addition or simple subtraction as we do in the arithmetic. Let me tell you some basic points of the addition and subtraction of the algebraic expressions. So, my dear students, it is going to be exercise 2.3. Maybe we start to it today or maybe in the next lecture. We'll be doing some examples also. So, rule number one is that the like terms like variables can be added. For example, if it is x, if it is x, then x can be added with x. It can be added with x. And if no coefficient is written over here, then I told you that it is always 1. It is always 1 when no coefficient is written over here. So what will happen over here, that it will become 1 plus 1, just like in arithmetic it will become 2, and the same same kind of variables are not added. These are just written as it is, because you see what is being added is the coefficient. Now coefficients are added, the variables are not added, but it is supposed that the variables are being added over here, because this variable has a coefficient of 1, this has a coefficient of 1, and same degree. And next is the, if it is of same degree, for example x square, let us say 2x and 3, these can also be added like this, 5x square. You notice that here again we have written just 5x square. We have not added any powers, not added anything else from here, but only what we have done is we have added the coefficients of the algebraic expressions. So this means that the like variables can be added, same degree variables can be added. For example, if we have x square and we do have also an x and we do have also an x cube, these cannot be added. You see that all of them carry 1, 1, 1 as their coefficient, but these cannot be added together. You cannot write it in this way or this fraction. This is remain as it is, like it is in this form. Now you see that 3x cube cannot be added to x square, and x square cannot be added to, and similarly in like a mixed variable expressions, you can also, now this is x plus y. If we are going to let me assign some coefficients to this. 2x plus 3y, let us do it in this way, 4y. Now if we are going to add these, it will simply become 7y and it will become 7x. Now it is very simple that we just add the like terms. But you see that this cannot be added to this cannot be added to this. Similarly is the case with the subtraction. Now what does subtraction do? It will be like this. It is the same. The rule is same. If it is going to be minus, there must be same variable, there must be same degree, and then you have to do the minus work. You see, and if it is like this, then it will become like this. Okay, so this was the one general rule of the addition and subtraction of the mm, algebraic expressions. Now dear students, our upcoming topic be simplifying expressions. Simplifying expressions. Now you see that if we have an expression which is written like this, 3a upon b minus, now this is an algebraic expression as you know that, but there you can see the three parts, 2 3a upon b and ab divided by c. Now these are three parts. Now these parts are called terms. You know that each part will be called term. Now this is term, and this is term. So each part is called term, and this very example of expression and the addition and subtraction of the terms is called an expression. Now this example have three terms, one, two, three terms. Now there are some examples that it have only one term, like this what I told you in my addition example, that this is only one term expression, this is two term expression. So there can be one term, there can be two term, there can be three term, or there can be more terms than three. Now as I told you that like variables can be added or subtracted to the like variables. Just I told you that x can be added with x. X is x cannot be added to x square. So y cannot be added to x, and y cannot be added to x square. Y cannot be added to y square even. So it means that if I call this a term, x is a term. So it means that the like terms can be added together or subtracted. The like terms can be added together or subtracted. Now for example, I have now dear students, notice that these are the like terms. don't just mix up the like terms with this coefficient. Now the constant over here does not affect the adding or subtracting ability of this term. It is free to be added with 3, or it can be subtracted because the sign is here a subtraction. So it is free to be subtracted or added with this one over here. Now I told you that if nothing is written, that means 1 is written over here. It is understood. It is general law. Now this 3 is free to be subtracted with 1. And this x square and this x square are xy square, and xy square are like terms, so it can be uh, subtracted. Since the subtraction sign is in between them, so the answer will become like this. So you see that nothing has happened to the terms, as I told you. The term is written as it is in this, uh, as it is in this term, as it is in this term, and it came similarly. It came as it is, like in the individual terms, and it appears to be the same in the answer. The second law, that the term means this, or you say like this, y square. Now you see that this term and this term, now this is first degree term and this is second degree term, because it is carrying 2 power over here. I can say it index. Now the indices of the both are 1 and 2 respectively. Now you see that this term can be added or subtracted with the same type of variable and indices over there. Variables and indices over there. No, it cannot be added or subtracted. It cannot be added or subtracted with this. These are not added. This cannot be added or subtracted. This is only be added or subtracted when only this thing will happen. Okay, we have to do some example to understand the concepts very well. Now there are examples. Work example 6 and the page is 30. Work examples, page 30. And you know what is the book? Which one is the book? So this one is the book, my dear students. Page 30. Uh, First example is simplify 4a, 2a and 3a. Simplify a, 4a, 2a and 3a. So what we have to check at the very first, that either the variables are same, and the degree or the indices are same. So all carry one index or power, and all variables are alike, a and a. So it is valid to be added together. It is valid to be added together. So simply we have to add the coefficient, not these variables. We have to add the coefficient. 4 plus 2, 6 plus 3, 6 plus 3, 9, and variable with its index will remain as it is. Now you see the index is 1 over here, which is not written. When 1 is there, we don't have to write 1 over here. So it will become 9a. It was very simple. Now there is another example, 4a, 6b, and 3a. Now again, our first step, what is our first step is that we'll have to check whether or not the variables are same. You see that these two variables are same and this variable is different. So leave this variable and just add the variables and their indices which are there. It is 1, it is 1 again. You, the both conditions are satisfied. Both conditions are being satisfied. So the variable is a, index is 1, index is 1. Go for addition for only these two terms. So it will become 7a and leave this 6b as it is. And leave this 6b as it is. Now the addition is completed. Similarly, we have part C over here, and it is 5x plus 2y minus 7x. 5x plus 2y minus 7x. Well, I think you will do it by yourself. Now here it is x, here it is x. Indices are the same, but what about this? Just leave it. But you have to write it in your addition, as we have written it in our addition, the final answer. We will not spare it. We will write it in our example, our answer. Now this is 5, this is 7. This is 5 and this is 7, and with the minus sign is greater than the addition sign, so the minus sign will appear in our answer. So 2x plus 2y. Now this can be further simplified if we want to, but the answer is correct up till here. Now you can go to minus, put the minus sign out with 2 and just do it in this way. This answer is also valid. This answer is also valid. You see that if you multiply 2 with 2x, it will become minus 2x, minus 2x. And if you multiply this minus with minus, it will become plus and plus 2y. So it is more simplified form than this. So, but the both answers are valid. Part D. 2p plus 5q. 2p plus 5q plus 3q and minus 7p. Now you see that this expression contains 4 terms, 1, 2, 3, 4, with 2 like variables and 2 like variables over here. So, and indices are the same. Indices are the same. So what we do, we will pick up p first because it is coming first. So 2p minus 7. 2 minus 7 is minus 5p minus 5p. Now this will become plus and plus again 8q. You can also write it 8q minus 5p. Sometimes we don't like to have minus in front. So we change this expression to 8q minus 5p. It will make no difference. It will make no difference. The last is, I think I don't have much more space now. The last is e to ab 2ab plus 3a square b plus 3a square b minus ab plus and again 3ab square. So dear students, we have to check it for two variables now. You see that this term is AB. Now just consider that AB is a single variable. We have to find ABs in our next terms, not A as a separate variable and B as a separate variable. Now AB, now it cannot be added with A square because the indices are not the same. Index here is 1, here is 2. The variables are same. However, if variables are same but index is not same, and you see that index of b is also same, but even then we cannot add ab with a square b because we have to look for ab with one index over here and one index over here. So this can serve our purpose because this is AB, this is also AB. Indices are 1 and 1, 1 and 1. So this can be added or subtracted with this. Now this term and this term are alike in terms of variable and indices, and rest of the terms are not alike. Now you see that this is a square b and this is ab square. So one, only two terms out of the four can be subtracted because there is a subtraction sign over here. So in the last, what will appear? ab plus 3a square b plus 3ab square. Yes, you can take common out of it. 1 plus 3b, sorry, ba. 3a plus 3b. Both answers are valid. You see that uh, made we have made this AB common because AB is existing in all the three terms. So we brought this common over here, and AB multiplied by 1 is AB, AB multiplied by 3A, A square B, and AB multiplied by 3B will become 3AB square. So this is complete. So dear students, I hope that this lecture is enough for today, and it is quite enough. We'll be starting exercise 2.3 in our next session. It is again a lengthy exercise, and maybe we'll be doing it in 2 or 3 sessions. I'll try to finish it in 2 sessions, but not less than 2 sessions. So it's time to say you goodbye. Allah Hafiz.